The James Webb Space Telescope, JWST, spotted something weird. Beams of light coming from what looks like a city on a planet light years away. This has people wondering again if there might be alien life out there. The telescope was aimed at Proxima Centauri b, the closest exoplanet to us, and it saw some strange, shimmering lights. Could these be signals from an alien civilization? We'll have to wait and see what else they turn up. For ages, both scientists and regular folks have been fascinated by the thought of life on other planets. Any hint of something out there gets everyone excited. But the JWST finding is big, suggesting life might exist somewhere out there in space. While checking out the huge universe, the telescope saw something unusual on a far-off planet. Flickers that looked like city lights, backing up the idea that there could be a city there. This has caused quite a stir because it could mean we've finally found intelligent beings living in ways we're only beginning to imagine. NASA folks are really surprised, seeing these city-like lights from so distant. They are wondering how long these lights have been shining before we had the tech to see them. David Kipping, an astronomer at Columbia University, said the planet where these lights appeared seems complex. Unlike most rocky planets that soak up sunlight and give off heat, this one acts odd because of how it interacts with its star, Proxima Centauri. This finding shows how important the JWST is, because it spotted the planet's weird behavior by detecting infrared light. This is really important for figuring out what its atmosphere is like. Scientists plan to keep using the telescope to check out the planet's weather. They want to know if life could survive there. The JWST is good at sensing infrared, so it can see what's happening on Proxima Centauri b even at night. While a lot of telescopes have trouble picking up faint lights in space, the Webb telescope is great at finding even slight glows. That makes it the perfect tool to confirm if those city-like lights on Proxima b are real. The instrument can spot artificial light if it's within a certain light range, which is smaller than the energy given off by stars. Proxima Centauri b is really affected by its star. Just like other planets, it gets a lot of radiation from Proxima Centauri. As it goes around the star, it gets light and dark periods. Like Earth, it gets really hot during the day and freezing at night, but the temperature differences are huge, based on what the planet is made of. If it has an atmosphere, the change between day and night would be extreme, with one side being really hot and the other really cold. Scientists are interested because the changes can tell them about the planet's atmosphere. The JWST can look at the planet's heat and learn about its climate. Interestingly, the telescope's path around Earth lines up with Proxima Centauri b's orbit, which helps scientists get detailed measures of how the lights change every 11.2 Earth days. Should Proxima Centauri b have a layer of gases, the following objective involves analyzing its makeup to gauge how habitable it is. Finding stuff such as oxygen, water vapor, or methane could mean the planet can support life. This means looking at the starlight as it goes through the planet's atmosphere, which is tough. Even though the JWST is great at figuring out what a planet's atmosphere is like, it was built for different stuff. It's best at finding water vapor, carbon dioxide, and methane. Seeing free oxygen, which is a big sign of life, is harder with the JWST. But it can still spot other key things such as ozone, which shows the atmosphere is pretty stable. As scientists check out the info the JWST sends, the search for alien planets goes on, which gets us closer to knowing if we're alone in the galaxy. The JWST can only check out some nearby exoplanets. So, to check out more alien skies, scientists will use land-based places such as the Extremely Large Telescope, ELT, scheduled to get up and running in 2027. The ELT should give us better looks at distant planet atmospheres, giving sharper, more spot-on info about their chance for life. Experts can't wait for new space tools such as the ELT. Meanwhile, the James Webb Space Telescope is still key for checking out far-off alien planets. Though it has some limits, it gives useful stuff that could change what we know about life beyond our solar area. Researchers are hoping for next-gen observatories. They want to make systems to make starlight weaker, allowing better looks at bodies in orbit. Almost like shielding your eyes from the sun to see what's close to it, these telescopes will look at the faint light from planets. This will let us see their skies better and know if life can live there. But things aren't easy. Stars are bright and drown out the dim lights from planets nearby, making it hard to see them. To take care of this, teams are building new ideas. One good idea is coronagraphs, tools inside telescopes that block starlight but let planet light pass through by shaping the light waves. Coronagraphs cut down on starlight, helping us spot faint planet signals. Another way to handle planet watching is with a star shade, a huge flower-shaped spacecraft that works with a telescope miles away. The star shade blocks starlight before it gets to the telescope, letting only the planet's light be seen. This has a good chance of seeing planets in their star's livable zones, where there could be water and life. These ways need things to be precise. Lining up a star shade with a telescope over huge differences has to be right to millimeters. And these parts need to be small, use little power, and last in tough environments. Despite these building challenges, the benefits could be high. Watching and learning about alien atmospheres could show biosignatures like signs of biology. Gases such as oxygen, methane, and water in certain mixes could point to life, giving some of the strongest proof of living beings somewhere among the stars. Researchers are seeking clearer visuals of alien worlds. Future tools might use smart adaptive optics to fix problems from Earth's air or telescope shifting, resulting in crisper, more spot-on visuals. When matched with light-blocking tools such as coronagraphs and star shades, these changes could allow scientists not just to find exoplanets, but to see what their surfaces are like and see their weather. Such imaging would be a big jump in knowing the ways of alien environments and seeing if they can support life. As we reach for the stars and make our tools for watching and reading cosmic wonders better, the worth of the James Webb Space Telescope, and the ones following, becomes even more key. It can see infrared patterns, letting it detect weak planetary heat, break down atmospheres, and pick out biosignatures that might mean life is there. Thanks to science gains and lots of space data, we're about to learn things that could change how we see life in the universe. Seeing lights made by someone or city-like lights on Proxima Centauri b, a close planet, could start a new thing in space research. This search doesn't just grab info. It also looks at tough ideas. What if we know we're not alone? How would seeing another species change human life? The excitement for Proxima Centauri b is a symbol of our strong interest and search for meaning beyond Earth. The next space telescopes, whether in space or on Earth. Even though the James Webb Space Telescope is awesome at studying atmospheres, it was mainly built for other stuff. It's really good at finding water vapor, carbon dioxide, and methane, but not as good at finding free oxygen, which is a big sign of life. Still, it can spot other key things like ozone, which suggests there's a stable atmosphere. As researchers look at the data from the James Webb Space Telescope, the hunt for alien worlds goes on, bringing us closer to finding out if we're alone in the universe. It's worth noting that the JWST can only look at a few nearby exoplanets. For wider searches, scientists will need ground-based telescopes like the Extremely Large Telescope, or ELT, which should be up and running by 2027. The ELT should give us a better look at distant planetary atmospheres, giving us clearer info about their potential for life. Scientists are excited about future tools like the ELT. In the meantime, the James Webb Space Telescope is still a key tool for exploring alien worlds. Even with its limitations, it keeps giving us valuable data that could change how we see life beyond our solar system. Researchers are hoping for next-generation telescopes that can block out starlight better, letting us study planets in more detail. Like using your hand to block the sun so you can see something next to it, these telescopes will focus on the faint light from alien planets, giving us a better look at their skies and whether they could support life. But it's not easy. Stars are so bright that they often drown out the faint light from planets, making it hard to see them. To fix this, engineers are working on new ideas. One is to use coronagraphs, which are special tools inside telescopes that block out starlight while letting planetary light through. Coronagraphs greatly reduce the starlight, making it easier to spot faint signals from planets. Another idea is the star shade, a huge flower-shaped spacecraft that works with a telescope miles away. The star shade blocks starlight before it even reaches the telescope, so only the planet's light gets through. This could be great for seeing planets in the habitable zones of their stars, where liquid water and life might exist. These new methods need to be super precise. Lining up a star shade with a telescope over such distances needs to be accurate to within millimeters. Plus, these things need to be small, energy efficient, and tough enough to survive in space. Even with these engineering challenges, the potential reward is huge. Studying alien atmospheres could reveal biosignatures, which are chemical signs of life. Things like oxygen, methane, and water vapor in certain patterns could be strong evidence of life beyond Earth. Researchers are also trying to find ways to see distant worlds more clearly. Future tools might use smart adaptive optics to fix distortions from Earth's atmosphere or telescope movement, making the images sharper. Combined with light-blocking tools like coronagraphs and star shades, these improvements could let us not only find exoplanets but also map their surfaces and watch their weather. This would be a big step forward in understanding alien environments and whether they could support life. As we keep exploring the stars and improving our tools for seeing and understanding the universe, the James Webb Space Telescope and its successors become even more important. Its ability to capture infrared light lets it spot faint heat trails from planets, study atmospheres, and find possible signs of life. Thanks to new discoveries and growing amounts of space data, we're close to discoveries that could change how we think about life in the universe. Finding artificial lights or city-like glows on Proxima Centauri b could be the start of a whole new chapter in space research. This ongoing quest isn't just about getting info. It's also about answering big questions about life. What would it mean if we found out we're not alone? How would meeting another advanced species change us? The excitement around Proxima Centauri b shows our deep curiosity and our search for meaning beyond Earth. The next space telescopes, whether in orbit or on Earth, will keep pushing the limits of what we can see. With better ways to block out starlight, sharper images, and wider coverage of the spectrum, we'll be able to study alien atmospheres more accurately. Besides finding biosignatures, future missions might even find technosignatures, signals or artifacts that suggest advanced technology. With each new mission and every piece of data, we get closer to answering one of humanity's biggest questions. Are we really alone in the universe?